All right. Okay, have a look at these. Here we go. Yep. Yeah, go ahead. Here we go. Put stuff away. I want phones away. Like, totally away, please. Notebooks out. You need your notebooks today? Okay, what I want to do, I'm gonna introduce one more new topic for chapter 5, and then before we move on to the end of the chapter and do the last section, I'll give you a chance to kind of work on this stuff. But all this stuff is pretty strongly related. So, I want to look at two relationships today. They're not really hard relationships conceptually, but what I want to do is I want you to get. I'll wait till everybody's with me here. I can see. I'm probably. I'll let you get your notebooks out. Do that first. Okay, now you get notebooks out. I need your undivided attention. You really got to focus on this. And if you do, the payoff is you'll get it, and these assignments won't be a big deal. If not, they will be a little challenging. Okay, so we want to look at these concepts, and then what we're going to try to do by the end of the day, and it's going to be a little bit of a push. We may not get through all this, but the goal is I want us to get through understanding the concepts, and then maybe moving towards how does this relate to using algebra. I'm going to give you some problems by the end of the period that are going to force you to have to kind of take the geometry relationships and turn them into algebra equations. And that's the most important skill in a geometry class that you'll get, is being able to make that connection. Okay, so one of the relationships is pretty simple. I want you to notice something here. It's hard, like I said, it's hard to see in the back, and I can't make these bigger for some reason. But I've got a triangle, and then I've got a point that's on the extension of one side of the triangle. And so what would I call this angle right here then? What kind of an angle is that? Obtuse. It's obtuse, yeah, it is. But I would say that these three angles are the interior angles of a triangle because they're on the inside. What's that one called again? Good, that's an exterior angle, right? So let's look at the measure of that exterior angle, and that's right there. Okay, and let's compare that to the measures of these two interior angles, right there. So let's look for some relationships. And this is one that's, after a while you're going to say, well, this is the way it had to be, and you'll tell me why. But let's try some things. I'm just going to tweak this triangle, and let's see if we can make, for example, angle B as big as possible. Okay, so to make that one as big as possible, I could maybe take the coordinates for angle, or for point A, and like drag it clear up here. Other way, sorry, up here. So angle B, let's maybe move this one down a little bit, right? So angle B is getting really big. Angle B is now, let's see, BAC. Oh, you know what? I messed something up here. Oops, I gotta fix one thing real quick. That one's wrong. It's the wrong angle. I want ABC, not ACB. So let's delete him. Oh, I don't want to do that. Just that guy, let's delete. There we go. And we want to measure this one, A, B, C. Okay, much better. All right, so I could make angle B really big, right? I can make it really big. There's 175, there's 176.3 degrees, 178.8. I could keep going, but as long as ABC form a triangle, what angle could I never get to? Yeah, 180, right? If I get it to 180, look what happens. If I get it up to 180, all of a sudden, that's no longer a triangle, is it? It's just a line. triangle collapsed into a line, or a line segment. So we know that, for one thing, we know that angle B is always going to be less than 180. Let's compare it, as angle B gets really large, let's compare it to the exterior angle, angle BCD, right? Which one's bigger? B's getting really big, but notice people that are sitting up front, which one's bigger? BCD is always a little bigger, isn't it? It's always a little bigger. Okay, let's try tweaking it a different way. Well, this time let's make angle A really large and angle B really small. So we'll do something maybe like this. Right, so angle B is getting really small and angle A is getting really large. BAC anyway, this angle down here. Once again, we could never get to 180, could we? Because at 180, the triangle would collapse. It would just be a line segment. And what's the relationship between the exterior angle and big angle BAC? Which one's bigger? Yeah, the exterior angle is still always bigger, isn't it? Right? So does that make sense? That no matter what we do, the exterior angle is always going to be bigger than either of the remote interior angles, the non-adjacent interior angles. Does that make sense? Could you have told me, duh, Mr. Roya, that has to be true because what? Is there a relationship there that we learned before that might be helpful? What do you think? Kristen?
The exterior angle adds to the two far interior angles?
Yeah, we had, back in chapter 4, we had the exterior angle theorem. And remember what that told us? That told us that the measure of an exterior angle is always equal to the sums of the measures of the two non-adjacent or remote interior angles. They always add up to be the same, and we can show that. We can do a little calculation here in Geometer Sketchpad. Let's calculate the sum of that angle, that interior angle, plus that interior angle. So there's the sum of those two. And what do you notice? What do you notice about those two? No matter what I do, the sum of those two interior angles always just equals the exterior angle, right? So doesn't that make sense then? The exterior angle inequality is really not a very important one. It's just, that's one of the two. There's only two relationships that section 5.5 covers, and that's one of them, and that's not that big a deal. The exterior angle by itself is always bigger than either of the two remote interior angles. It's always true. Okay, so there's one. More importantly, though, let's look at this situation. Now I've got these three segments, and our goal is to make a triangle out of these three segments. So we've got segment AB, and there's the length of AB. We've got segment, oh, you know what I did? All right. Did something else kind of dumb here. I was doing lots of dumb stuff. Let's call this C, and let's call this D. How about? There, that's better. Okay. So now we've got the length of AB, we've got the length of AC, and we've got the length of BD. So you may not be able to see those, but I'll read them off to you. The length of AB is 12.7, the length of AC is 6.6, and the length of BD is 8.1. Could I pivot those sides down to form a triangle? I could. No big deal, right? And I can pivot this one down and this one down until they meet. I'm probably not going to get it exact, but you get the idea. I mean, they meet, they form a triangle, don't they? Right? No big deal. No No surprise. Okay, let's change the length of one of these though. Let's go ahead and change the length of this side. Let's make it like 3 or 4. Make these nice round numbers. Let's make this one 6. And let's make this one 12. Are those going to pivot down and form a triangle if I've got 6, 4, and 12? Could I pivot those down and make a triangle? Let's try. See what happens. Swing this guy down and that guy down. Uh-oh, what's the problem? Too short. How come the first one worked but the second one didn't? Okay, because the 2 shorter ones weren't big enough in the second case, but they were in the first case. So what do you think has to be true here? Can you tell me something that always has to be true for any triangle then? What do you think? Tell me this. What's the smallest I could make this segment right here to make it fit? If this one is 6.0 and this one is 12.0, what's the smallest I could make BD so that I could have a triangle?
6.
What would it be?
6.
6? Okay, let's make it 6. If I make it exactly 6, then if I swing these down, they're going to meet right there because that's going to add up to 12 and that's going to add up to 12. Is that a triangle? No. So 6 didn't work. Okay. So there's another, I heard somebody say 7. We could do 7, right? If I make this one 7, yeah, then it works, right? They're going to meet at a triangle somewhere in there. We can see they're going to, right? But it looks like I could have gone smaller than 7, couldn't I? Could I have done 6.5? I could have, right? What's the smallest I could do? Okay, I could do 6.1. That's going to be a strange looking triangle, but I could make it work, right? I guess it's going to be not quite. I almost got it. Right about there. Something like that. 6.1 and 6. Could I have gone smaller? I mean, I couldn't if I'm only measuring these out to the 10th. But what if I measured them out to the millionth or something? Right? Couldn't I go smaller? Give me an example of a side length that would work over here that's less than 6.1. Say it again?
6.05.
6.05 would work, right? It would work, wouldn't it? What's another one that would work? It's going to get pretty hard for me to make the connection up here just because I'm limited by the accuracy of the Promethean board. But 6.05 would work. What's another one?
6.01.
6.01. What's another one? Even smaller. 6.001. Would 6.00000000001 work? It would. It's going to look pretty much. It's not going to look like much of a triangle, but if I enlarged it and magnified it, I would eventually see that it is a triangle, right? So what's the condition then? We could sit here all day and you could throw out values that would work, but how could we represent all the possible values that would work for this segment right here? And just say it one time and have it include all of the infinite possibilities. The length of segment BD would have to be what? Greater than 6, wouldn't it? Right? Would have to be greater than 6 because what did we decide? You fill in the blanks for me here. In a triangle, the lengths of the 2 shortest sides must be what? Greater than, right? The sum of the lengths of the 2 smaller sides must always be greater than the length of the longest side for the triangle to work. Otherwise, they don't make the connection when we pivot them down, right? Does that make sense? Okay, so
more than 12.
So, right, so these two added up would have to add up to some number greater than 12 in order for them to be able to meet, right? Okay, so we could look at this a couple ways then. So we took the example here where AB was the longest side, but it doesn't have to be, right? I could also, whoops. If we're trying to find the lengths of side BD that work, well, what if side BD became the longest side? What if side BD became, let's say, 13? If side BD became 13, now, and side AB is 12, now what about AC? How big could AC be? What's the smallest it could be? What's the smallest that it could be? Let's move this one down here. So here's AC. Clearly it's gonna work there, isn't it? It's long enough, right? What's the shortest it could be? Okay, 1's gonna be the limit, isn't it? If I move this thing down to, if I move this guy down, there we go, to where, oh, that's not one, never mind. If I move this one down to like 1, that's not quite big enough, is it? Because that's not quite, if I want to make all those connect, look what I'm going to have to do. I'm going to have to connect them so they collapse and form a line segment, right? Does that make sense? It's going to have to be some value a little bit bigger than 1, isn't it? It's going to have to be a value like, let's say, 1.1, for example. Now, I get this all messed up, all right? So now, we should be able to make that work, right? Everybody agree? Okay, so the smallest, what could you tell me in this case? If BD is 13 and AB is 12, then what could you tell me about the length of AC? Has to be greater than 1, doesn't it? Right? Does that make sense? Okay, that would have to be the case because now the longest side is 13, and so the two shorter sides would have to add up to a number that's greater than 1, right? Everybody see that? Okay, so you tell me then, would these numbers create a triangle? These side lengths, could they create a triangle? What if I had a triangle with side lengths 12, 7, and 4? Does that work? No. Doesn't work because 7 plus 4 is not greater than 12, right? How about 12, 7, and 8? Does that work?
Yeah.
How about 12, 7, and 18? Okay, that works, doesn't it? How about 12, 7, and 19? Does that work? What do you think? No, how come? Okay, because we didn't meet our condition, did we? That form a line segment. Because the two smaller ones have to add up to a value greater than 19, and they don't. They add up to 19, right? Okay. So let's go about this another way then. I'm going to tell you, we've got some triangle. I'm not even going to draw it. We've got some triangle XYZ. Here's what I'm telling you about that triangle. The length of side YZ is 7. The length of side XZ is 11. Okay, I want you to see if you can come up with all of the possible lengths of the missing side, which is side XY, that would make a triangle. Okay, you got to think about that. Take a second, think about it. Maybe you probably have to write something down. Maybe consult with your neighbor for a second, and let's see if we can come up with an answer for that. So we want to know what lengths. Here's the question you're answering. Okay, suggestions here, let's take a look. Okay, so what can you tell me? Tell me something about, Bailey, what do you think? Tell me something about the length of XY. Tell me one thing that has to be true. You know, I'll get you started. Let's assume for a second that XY is the longest side in the triangle. What can you tell me about it? It has to be what? So you fill in the blanks then. So XY what? It's the longest side. Now what's our rule? What did we say? Somebody remind us, what's our rule about triangles we just said? The lengths of the two shortest sides have to be greater than, right? So that would mean then, whoops, sorry. Okay, so that would mean that the length of the longest side has to be less than the other two combined, right?
Yeah.
Okay. So we're gonna find maybe its upper limit, right, Alec?
Right.
Okay, the upper limit, the biggest, it has to be less than what upper limit then? What's it gonna be? 18. It's gotta be less than the other two combined, doesn't it? Or it'll be too long and they won't touch. So it's gotta be less than 18. There's part of it. Okay, now let's assume, and you gotta be, listen real carefully with this one. If XY is not the longest side in the triangle, then which side would be the longest side? XZ. So the longest side in that case would be 11, wouldn't it? Right? So now we got to think about the smallest it could be. Okay, what's the lower limit going to be? XY is going to have to be greater than what if this is the longest side?
Like, it has to be lower than that, right?
So it's got to be less than 18. If XY is the biggest side, well then the biggest it couldn't be too big. It'd have to be less than 18.
So it could be 12.1.
It could be 12.1. What's the smallest it could be though? Could it be 6?
Yeah.
Yeah. Could it be 5? Okay. What's the lower limit? It's got to be greater than what value? 4. Yeah. Right. Everybody see that? Because whatever its smallest value is, that value plus 7, the other smaller side, would still have to be bigger than 11, wouldn't it? Okay. So we can probably just power through that mentally or intellectually. But how could we have done that maybe algebraically? The first part's probably pretty simple. Everybody probably jumped on that one pretty quickly. But the second one was maybe a little trickier. How could we have asked the math gods for a little help here? And they give us help with algebra. So we could have probably said this, right? We could have said, we don't know what the lower limit's going to be, but we know that XY plus the other short side, 7, has to be greater than the long side, which is 11, right? Okay, now let's talk about this right here. That looks a little different. We haven't done very much algebra this year, if any, with inequalities. So we've got to kind of think back to Algebra 1 for a second. Inequalities work almost exactly like equations, and you guys are awesome at this point. You're very, very good at doing algebra with equations. Yeah, I mean, that's very happy with where we are in that regard. We haven't done a lot of this. The only difference is, I mean, there's a couple differences, but really the only one we're going to have to be concerned with at all is if we're doing algebra with an inequality and we divide both sides of the inequality by a negative or multiply both sides by a negative. Do you remember what we have to do? Take a quick example. Unrelated to this problem. Let's say I've got negative 3x is greater than 15. What's the step I would do to get x by itself? What would you do with an equation if you want to get x by itself? Divide by negative 3. Okay, so if I divide by both sides by negative 3, what's that going to give us on the left side? X. On the right side, it's going to give us negative 5. Okay, but what's the really critical part here? What do we have to do if we multiply or divide by a negative? We got to flip the sign, right? We'd have to flip that from a greater than to a less than sign. That's easy to forget, right? Otherwise, the algebra is all the same. That's the only difference. So because that can be a little tricky, when we're solving a situation like this, we'd always like to to do the algebra in a way where we don't have to multiply or divide by a negative, if possible. Well, here it's not a problem. What's the only step we have to do to get the variable by itself? How do I undo adding 7? Subtract 7, right? So I'm just going to subtract 7 from both sides, and it ended up not being a problem. We'll look at an example in a second where we got to be a little more careful. But we end up with the result then, xy is greater than 11 minus 7 is 4. Well, isn't that what we got right there? Okay, you see that? See what we did is we just combined two things. We said, on the one hand, xy has to be less than 18. On the other hand, xy has to be greater than 4. So we're going to write those as a compound inequality, right? So this is, if we take that whole thing, that's what we call compound inequality, because it's merging those two inequalities into one. But it's in a way that makes sense, doesn't it? If we look at this, this is a great way to state it. Because we've got xy, which is pinched between the lower limit of 4 and the upper limit of 18, right? How do we say that? We'd say xy is greater than 4 and less than 18. All those values would be fine. Okay? Let's try another one. Does that make sense? So with these values for the other two sides, these are all the possible values of the missing side xy. Okay, let's try one more. I want to see if you can come up with an inequality that solves, if we have triangle ABC, and I'm telling you that BC equals 7 and AC equals 10, I want to know what are all the possible values of AB. Okay, take a second, see if you can come up with a compound inequality that tells me what values AB has to be pinched between. Alec, if AB is the longest side, what can you tell me? AB has to be what compared to the other two sides? What do you think? Or another way of saying it would be the other two sides, 7 plus 10, whoops, that's back 10.
Greater?
7, what, AB has to be greater? Okay, so AB has to be greater than what?
BC. Wait, no, I don't know.
With the other two sides there, 7 and 10, what do you think? Okay, well let's, if AB is the longest side, could AB be 1,000? If AB had a length of 1,000, that would make a triangle? It's not going to quite do it, is it? That's way too big. Those sides aren't going to be able to reach. Could AB be 20? No, can't, too big. Could it be 16?
Yeah.
Well, 16 would work, wouldn't it? 16 would work. Okay, so AB has to be less than what value? Yeah, it has to be less than the sum of the other two, right? Everybody agree? So there's half of the statement is done. We know that AB has to be less than 17. That's the upper limit. Otherwise, they won't touch. Okay? All right, Justine, what if AB is not the longest side? What would be the longest side then? What do you think? If AB is not the longest, what is the longest? AC would be, right? So the longest would be, in that case, would be 10, right? So now AB is one of the shorter sides, right? And we know that there's two shorter sides, 7 plus AB would have to be what? If 10 is the longest side, in order for them to be able to reach when we pivot them down, greater than, right? Have to be greater than, the two smaller sides would have to add up to a number greater than the bigger side. Okay, so what do we do to solve for AB there? Subtract 7, right? So if I subtract 7 from both sides, we just get AB is greater than what? 3. So there's the other part of the limit, right? That's the lower limit. So then on the other side, we're going to say AB is greater than 3, and so that's our compound inequality, isn't it? All the values between 3 and 17 would work. Other ones would not. Does that make sense? Okay. All right. Got 5 minutes, right?
Yeah.
I'm gonna stop there. I don't want to do. That's probably enough for all in one day, right? Okay, so we'll come back on Monday and just have one more little piece.
What are you?